Okay, in this video we are going to talk about rational expressions. Now, a rational expression is any number that takes the form some number over another number. This is called rational. Now, as long as the number in the denominator is a rational number, then what we have is a rational expression. In other words, numbers like the square root of 2 or pi, right? These are irrational, and so these are not okay. These are not allowed as the denominator, and we in order to have a rational expression. If we have numbers that are irrational, then we don't have a rational expression. Another number that's not allowed in the denominator is 0. 0 is not allowed as a denominator. Why not? If you recall, any rational expression, any fraction, we'll say, is really an expression of a division problem. This one says b divided into the, let me use a different color here, actually. Let's use blue. This expression is really a fancy way of saying b divided into the number a. So let's see how that might work for an expression where we have a 0 in the denominator. Let's take the number 4 divided by 0, and I'm going to tell you that this number is undefined. Now, what do we mean when we say that a number is undefined? What that is to say is, if I were to take the number 0 and divide it into the number 4 and ask myself, what can I multiply by 0 to get the number 4, or somewhere close to it? Now, if you think about that for just 1 second, there is no number in the world, no real number in the world, that can accomplish this task. Why? Because any number times 0 is 0. I could put 4 up here, but 4 times 0 is 0. I could put 1,000 up here, but 1,000 times 0 is 0. No matter what, I won't get anything anywhere close to 0. And so it's for that reason that we are not allowed to divide any number by 0. When we divide a number by 0, we have what's called an undefined expression. So let's take a look at an expression and see if we can find where this rational expression is undefined. Now, as we can see, we have an expression that is clearly rational because we have what can be expressed as a rational number up here. Let's do that in a different color. Let's do that in green. This is a rational expression in the numerator, and we also have an expression in the denominator. But are there any numbers that will not work for x? Is there a number that if we were to plug it in for x, if we were to substitute for x, then we would get a 0 in the denominator, and thus we would have an undefined expression? What number can x not be? That's what we're asking ourselves right now. Well, if we took a look only at the denominator in this expression, and we set that equal to 0, if we said that x minus 3 is equal to 0, then we would know that our expression would be undefined. And so we have a very simple algebraic solution here. You know how to do this from Algebra 1. You would use the addition principle to isolate the x on one side of the equation, and you would get that x is equal to 3. So we know that if x is equal to 3, then the denominator is equal to 0, and this entire expression would be undefined. So we would say that x cannot equal 3, such that if we were graphing this on a coordinate plane, whatever the graph would look like, 1, 2, 3, the expression would never touch this. This line would never be touched by the expression. So now we can understand what we mean when we're talking about an undefined expression, where x is equal to 0. In the denominator, our expression is undefined. Let's practice another one of those. We'll call this one example 1. And this was a simple rational expression. We had a simple binomial on the bottom, and we found that from this binomial, x could not equal 3. Let's take a look at another example where you have to do just a little bit more work. The example is here is the quantity t minus 5t over t squared minus 3t minus 28. Now we still need to know, in this case, what values of t, what can t not be, in order to keep this rational expression defined. If we had a value of t that would make the denominator 0, then this expression would be undefined. Now, we know from experience that t squared minus 3t minus 28, that this here is a trinomial, and that in a lot of cases trinomials can factor into two binomials. So you did this in the last chapter. We'll go through the steps really quickly, but recall that this is review at this point. And this is why we did this in the last chapter, so that we can work with rational expressions. So if I were to take, let's use the AC method, and by the AC method we are going to take the coefficient of a, the a term there, and we'll take the the c, which is the negative 28 here, and we will multiply them. And we know that here we have some number which is a 1, right? 1 t squared is 1 times t squared. So 1 times negative 28 gives us a negative 28. And what we want to do is factor negative 28 so that the magnitude of the difference between them is a negative 3, right? So what are all the factors of 28? 1 and 28, 2 and 14. That's not going to give us the difference of 3. 3 and no number, 4 and 7. And here is a prime candidate. Right here we have the difference of magnitude 3. Now 28 is negative, which means one of these is going to be negative. The middle term is negative, which tells me that the bigger of the two terms is negative. So we have a minus 7 and a positive 4, and that'll give me a minus 28. Minus 7 plus 4 will give me a minus 3t. So here's where we employ our area model, and I like to use the area model, so let's continue doing that. Remember, with the area model, we put the first term in the first box, t squared. Let's do that in a different color. Let's do that in a pink. I like pink. T squared goes in the first box. The last term goes in the last box, minus 28. And the two middle terms are both t terms. I'm going to have a positive 4t here and a negative 7t here. And it doesn't matter whether you put the negative 7 up here or down here. It's just that we want to make sure that those are the middle terms. Now our area model tells us that we need to factor out all of our like terms going across and down. So t squared and 4t both have a t in common. And negative 7t and negative 28 both have a 7 in common. And let's say it's a negative 7 because these are both negative, right? So I have t minus 7 over here. Down on the bottom, I have t squared minus 7t, both have a t in common, and 4t and 28 have a 4 in common. So in this case, I have t plus 4 and t minus 7. Those are my terms. So remember that the zero principle tells us that for any two numbers, a times b, if a or b is equal to 0, then either a is 0 or b is 0. One of those two has to be the case. Well, here I have two numbers. Do I not? I have an a here and a b here, which is to say that t plus 4 is equal to 0, or, and that or is important, t minus 7 is equal to 0. And again, we have a very simple algebra problem. We can say that t is equal to negative 4 or t is equal to 7. And so here we know that if t is either of those values, negative 4 or 7, then my expression up here, circle that in red, this expression becomes undefined. And the reason that becomes important is in case we're ever asked a question about the domain. What's the domain of the expression above, right? Remember, the domain is the set of all numbers in the x value, right? So the set of all x values can be any number in the world. Any number is going to make this a rational expression except for two numbers. You see, if I put in a negative 4, well, let's put it this way. If I put in a negative 4 in the spot for t, then the denominator is going to come out to be 0. Also, if I put a positive 7 in the denominator for t, then the denominator again will come out to be 0, and that's simply not allowed. So as for the domain, the set of possible x values that can satisfy this equation and generate a range, so this will be equal to some y, right? Y is going to be t to the 4th minus 5t all over t squared minus 3t minus 28. T, oops, I put x. Silly. Nobody caught that. T can be any number in the world except negative 4 and 7. That'll be the end of chapter 5.1, where we have talked about rational expressions, what a rational expression is, and how to find an undefined value for a rational expression. In the next video, we are going to move on to other kinds of rational expressions, how to simplify them, how to multiply them, and in some respects, how to divide them. All right, this is Mr. Rodriguez.